Ladies and gentlemen, we're going to do a steroid question for test 4 from fall 2019. And what we have here is a steroid. It has the A, B, C, D ring system, which is always 6 next to a 6, upward to the right to a 6, then to a 5. And this next ring is actually not normal for steroids. It's unique to this one. So a little reminder at the bottom of the page and a caution. You have to learn this numbering system. It will not be given to you on the test. So you have to learn that steroid numbering starts with carbon number 1 on the A ring, and it's to the left of the bridgehead to the B ring. And then it loops around 1, 2, 3, 4, 5, and then continues around for the B ring to 10. So I'm just going to number our steroid. And that gets you to 10. 11 is the bridgehead, next to the bridgehead from B to C. It's up here. I'm just copying what's down on the bottom of the page, although you won't be able to copy on the test. 14, 15, 16, 17. And then, strangely, it jumps to 20 because steroids almost always have a methyl group here off of 13 and a methyl group here off of 10. That would be a normal steroid, and we have these 2 normal methyl groups here. Now, in a later question, when you're supposed to tell me what groups are on the steroid, that's our next activity, by the way, you won't tell me about these methyl groups unless they're missing, because I only want to hear about unique things. So let's put our numbers on. 18 is that methyl, 19 is this methyl, then 20 off of 17, which goes to another methyl for 21, and 22, and carry on, 23, 24. This is a 24 prime. It's rare. It's rare. That's why it's got a weird numbering. It's not often you have a methyl there, but I'm following this pattern. If you have a methyl on 24, it's called 24 prime. We don't have a 24 2, so don't label it. 25, 26, and the methyl's 27. 25, 26, and the methyl is 27. And what we're supposed to do in this question is tell the instructor what groups are on the steroid. Indicate all the groups on the steroid and tell me their position. That's why we put the numbers on there. All right. So on carbon 3, there's an oxygen, and you need to tell me. You need to tell me what kind of an oxygen it is. What functional group is that oxygen a part of? Don't say an ether. Yes, it's an acetal. And use the labeling that's there to sugar C. Isn't that a correct assessment? The sugar labeled C, which you will be naming later. Yeah, this is a common thing that steroids are hooked up to small polymers of carbohydrates. They're called oligosaccharides. Remember, oligo means a few or several. It's not uncommon to see a steroid hooked up to a oligosaccharide. What do we have on carbon 5, 6, 8, 9? Let's just do them together. 5, 6, comma, 8, 9. Just say pi. There you go. That covers it. I need to know about any pi bonds in the ring. We have a couple ketones. So tell me on 7 and 11, you've got ketones. What else we got? We got alcohols. Careful with the alcohols. I need more than just alcohols. So here's how I'm going to do the alcohols. Alcohols. I see a tertiary on 14. Tell me it's tertiary, please. That's half the credit. A secondary on 12. Secondary on 23. I guess I could have grouped 12 and 23, but you know I didn't. So here we go. And I think I got all the alcohols. Yeah. And then we have what has to be called an ether between 16 and 22. 16 connected to 22 with ether. Right there, 16, 22 ether. And tell me where the steroid ends. It ends at 27. So actually, that's the maximum any steroid can have, right? So you don't even have to tell me it's special because this thing ends at 27. But the 24 prime, I told you, is a special thing. I need to know about it. So methyl has methyl 24. It's not really prime, it's a 1. And I think we've got everything we need to talk about there. And that part's covered. And we'll move on. We got to do the linkages now then. And I just want to remind you that when linkages are trans, it's alpha. So the linkage called C is alpha. The linkage here is also, whoops, I didn't do a very good comparison there. It's to this C here. And this O, if they're trans, it's alpha. Similarly here, for B, alpha for C, alpha for B. I can't do the sugar A yet because it doesn't have a carbon sticking off the ring. So I need to use the fallback position. But the fallback position depends on whether it's a D or an L sugar. And the fallback position for D sugars is what your biology teacher told you to learn. That alpha is down and beta is up. But that's only good for D sugars. They didn't tell you that. You got to draw the line somewhere. It's biology, not chemistry. Okay, so we're going to have to unravel A before I figure out if this is alpha or beta. I'm going to do it now. Why not? I have to name this sugar down here anyway. Oh, I didn't copy that part. Another part of this question is to name the sugars. So although it's not part of our activity right now, it would be part of your exam question if you go to 24, Fall 19, Test 4. You'll be naming the sugars too. Very comprehensive question. This came from an aldehyde, and I know you've been practicing these so much that you can go straight to the Fisher now. I know that's not true, but you need to get to the point where you've been doing all the steps for determining the names or the drawings of the cyclic monosaccharides so that you can get to here. And I don't expect you to do it this fast. That's an up left, that's an up left, and that's a down right. Up left, down right. And this is one of the rare cases where the carbon's in the loop already. So the CH2OH is here. And this is a D sugar. And we're going to look up the D sugar that has 5 carbons and goes left, left, right. Somebody can do that for me right now. I need the D sugar that's got 5 carbons, so it's not on the bottom row, the second from bottom row. And it goes left, left, right. And I'll start by writing D something. All right, while I wait, I'm going to do the D linkage here. And that's a beta because there's, oops, didn't point very well there. This is the same side as the O. That's a beta sugar for D. What is the name of my sugar here? LYXOSE. So it's a D sugar because this is on the right. So you can use your biology definition. When the anomeric O is up in a D sugar, it's beta. If that was an L sugar, I would say alpha. It is not an L sugar. And then just do the carbon numbers. Carbon numbers in pink. We got 1 on this sugar, 2, 1, 2, 3 on this sugar, 1 to 3. And there we go. We're going to go green on the next one. The linkage for sugar B is a 1 to a 1, 2, 3. So 1 to 3. I think this color scheme is going to confuse me. So I'm not even going to try. 1 on this sugar is hooked up to, no, it's not 3. My goodness. It's not 3. There's where it's connected. It's not 3 at all. It's 4. That looks bad. Sorry about that. 4. And then linkage down here, 2 to carbon 1 here. That's linkage D, 2 to 1. And linkage C is 1 to 3, but the 3 is a steroid. Tell me you know that. There you go. And there you have it. Good video. So you're going to get points for doing it this way with steroids and the other way. Your next activity, we're going to construct a steroid from scratch based on words. Oh, I bet you're excited. Coming back real soon.